Hello. So in today's class, we will look at partition of a given set, then how to find the number of partitions, and what are called the bell numbers. So these are the topics we will see in today's class. So suppose you are given a set A equal to the set 1, 2, 3, etc. R. Now by an n partition of set A, we mean that is a collection of subsets S1, S2, etc. Sn, and they must be non-empty subsets such that Si intersection Sj is equal to phi, and when you take the union I equal to 1 to n Si, that will be equal to A. So given a set A, we are going to look at an n partition. Of n partition that is collection of n subsets such that the subsets are disjoint, and when you take the union of those subsets, that will give your original set A. So such a collection is called S1, S2, etc. Sn. ഇനി നമുക്ക് S1, S2, etc. Sn നമുക്ക് പല രീതി ചൂസ് ചെയ്യാം. So the restriction on Si is all the Si must be non-empty, and these two conditions are there. അപ്പം ഇങ്ങനെ വരുന്നത് പോലെ you can find different n partitions for the set A. Now a partition of A is an n partition of A for some n equal to 1 to etc. R. അപ്പം നമുക്ക് നമ്മൾ എടുത്തിരിക്കുന്ന സെറ്റിൽ total R objects ആണുള്ളത്. So if you have to form non-empty subsets, അപ്പോൾ നമുക്ക് n ന്റെ value നമ്മൾ n partitions എടുക്കുമ്പോൾ maximum I can have up to R partition. I can have one partition. It means you will get the set itself in that case. Then two partition. അപ്പോൾ തന്നിരിക്കുന്ന set A നെ എനിക്ക് രണ്ട് set S1, S2 ആയിട്ട് എനിക്ക് divide ചെയ്യാം. അതുപോലെ S1, S2, S3 ആയിട്ട് divide ചെയ്യാം, or I can divide S1, S2, S4, and the maximum possible number of partitions will be S1, S2, etc. SR. So a partition of A is an n partition of A for some n equal to, so നമ്മൾ n partition എന്ന് പറയുമ്പോൾ n partition there n can be equal to 1, 2, 3, etc. R. And now the concept of n partition is something similar to the concept of equivalence classes. Given a set S, when given a relation R on a set A, we have seen what are called നമ്മൾ നേരത്തെ പഠിച്ചിട്ടുള്ളതാണ് what are called equivalency classes. So a binary relation is an equivalence relation if it is reflexive, symmetric, and transitive. So if R is a equivalence relation, then A can be partitioned into what is called equivalence classes. Equivalence classes name പ്രത്യേകത ഇതായിരിക്കും, they will be disjoint and their union will form the entire set. And now when you form the n partition, the n partition can also be, അപ്പം നമുക്ക് ആ സെയിം പ്രോബ്ലത്തിന് പല രീതിയിൽ നമുക്ക് നോക്കാം. ഒന്ന് partitioning a set, then it can be like finding the equivalence classes, the number of equivalence classes, then it can be also looked in the form of finding the Stirling's number of second kind. For here Stirling's number of second kind എടുക്കുമ്പോൾ there we look at the number of ways of distributing R objects to n identical boxes such that each box is non-empty. So R objects ഉണ്ട്, അതിനെ നമ്മൾ n ആയിട്ട് പാർട്ടീഷൻ ചെയ്യാണ്, n ബോക്സിലേക്ക് നമ്മൾ സെപ്പറേറ്റ് ചെയ്യാണ്. ഇനി നമ്മൾ ബോക്സിലേക്ക് ഒബ്ജക്റ്റ് ഇടുമ്പോൾ their ordering doesn't matter. That means you will be forming something like what is called the subset. So we need to find the non-empty set such that അപ്പോൾ ഒരേ ഒബ്ജക്റ്റ് എനിക്ക് ഒരിക്കലും രണ്ട് ബോക്സിൽ ഇടാൻ പറ്റില്ല. അപ്പം their intersections will be equal to phi, and when you take the union you will get your entire set. So a way of distribution of R distinct objects to n identical boxes such that no box is empty can be regarded as an n partition of the set A equal to 1 to etc. R. Therefore, by definition, so when you take the Stirling's number of second kind, S of Rn counts the number of n partitions of A. So, where A is containing exactly R objects. The total number of partitions of, so S of Rn will count the, S of Rn, this is the number of ways of distributing R objects to n boxes. So, S of Rn will count the number of n partitions of A. Now, the total number of all such partitions will be summation n equal to 1 to R S of Rn. So, summation n equal to 1 to R S of Rn denotes the number of partitions of the set 1, 2, 3, etc. R. So, here we are looking at the 1 partition, 2 partition up to R partition. And again, this sum is equivalent to the number of equivalence classes. So, this is also equivalent to the number of equivalence classes also. So, these are two ways of looking at summation n equal to 1 to infinity S of Rn. So, that is the number of partitions of the set or the number of equivalence classes defined on the set A. So, for example, let us look at how many partitions are there in a set of 3 elements. So, if you want to find the number of partitions in 3 element set, that will be given by summation n equal to 1 to R. So, you can have 1 partition, 2 partition and 3 partition. So, there are 3 objects. So, that will be S of 3n, where n varies from 1 to 3. So, that will be S of 3, 1, S of 3, 2 and S of 3, 3. So, S of 3, 1 that is number of ways of distributing 3 objects to 1 box. So, that can be done only in one way. S of R minus 1 നമ്മൾ കണ്ടു. S of R minus 1 എന്ന് പറയുന്നത് RC2 ആണ്. So, here 3C2 will come. And S of RR, that is the number of ways of distributing R objects to R boxes. So, that is again, that can be done only in one way. So, the number of 3 partitions will be, number of partition of 3 elements that will be 1 plus 3C2 is 3 plus 1. So, you will get 5. So, there are 5 partitions for a 3 element set. Now, if you have a 4 element set, then let us look at the number of partitions. So, that will be summation n equal to 1 to 4. You will get summation n equal to 1 to 4 S of 4 and verum. So, that will be S of 4 1 plus S of 4 2, S of 4 3, S of 4 4. So, S of 4 1 will be equal to 1. S of 4 2 edukumbo, S of 4 2 will be, you can write 4C3 plus 3 verum, and S of 4 3 will be equal to R minus 1, 4C2, then S of 4 4 will be equal to 1. So, you are going to get 5 plus 4C2 is going to be 6, 4C3 is 4 verum. Okay, so that will be equal to 50. So, that will be the number of 4 element partition of 4 element set. Now, if you come to 5 element edukumbo, summation n equal to 1 to 5 S of 5 and verum. So, you will have S of 5 1 plus S of 5 2 plus etc. S of 5 5. So, you can use the kanda standard values വെച്ച് നമുക്ക് ചെയ്യാൻ പറ്റും. S of 5 1 എടുക്കുമ്പോൾ 1 വരും. S of 5 2, so S of 5 2, you can use ഒന്നെങ്കിൽ recurrence relations use ചെയ്യാം. Okay, നമ്മൾ ആദ്യം കണ്ട നമ്മൾ prove ചെയ്ത recurrence relation S of Rn is equal to S of R minus 1 n minus 1 plus n into S of R minus 1 n. So you can either use that recurrence relation or that formula use ചെയ്യാം. Then so using that you will get S of summation S of phi n to be equal to, so the value is 52. So please verify that by yourself. And so those are a few number of partitions, and now we have seen the summation n equal to 1 to R S of Rn. So this sum is usually denoted by BR, and it is called a Bell number. So the Bell number is defined as summation n equal to 1 to R S of Rn. So Bell number actually gives the number of n partitions of set of R elements. So these are a few Bell numbers. So with this we will wind up the first module. So in the next session we will start the second module. Thank you.